In this video, we're going to go ahead and discuss the cliff problem, where a ball is being launched off horizontally off the cliff. So we've got this cliff, and this is a poor rendition of the cliff. But anyways, um, you've got a ball right here. It's traveling horizontally, and that's its velocity. I'm going to write down Vx, horizontal velocity, call it an average velocity because we're going to say this is a frictionless surface, so the ball is going to maintain a steady velocity. Let's give it a velocity of 5 meters per second. That means horizontally it's traveling 5 meters every second. So every second the ball is going 5 meters to the right. Um, and if you give it 2 seconds, then it's gone 10 meters to the right. Then it's gone 3 seconds later, it's 15 meters to the right. But when the ball reaches the edge of the cliff, it's going to fall off the edge of the cliff. So it's going to start developing a vertical velocity. And the reason why it's going to develop a vertical velocity is because there's this acceleration of gravity. Once again, you can write it as A or you can write it as G. Either case, the acceleration of gravity is negative 9.81 meters per second squared, or you can round it to negative 10 meters per second squared. Remember, when you're working with websites or when you're working with experiments, stay with negative 9.81 meters per second squared, but when you're working with word problems, you can round it to negative 10 just to make your math a little bit easy. So when the ball gets launched off of the cliff, it's going to start to develop a vertical velocity, and the ball is going to take a parabolic path, and it's going to reach right here. And we want to analyze it right before it hits the ground, because after it hits the ground, we have to discuss many other forces that come into play that we want to discuss at a later time. So right now, the horizontal velocity is 5 meters per second. Well, the question is, what is the initial vertical velocity? What is the vertical velocity? And right here, the vertical velocity is 0 because it has no vertical velocity. But as the ball gets launched, it starts to develop a vertical velocity. Now we're going to say that it's traveling through negligible air resistance, or you can say it's traveling through a vacuum, so nothing is impeding the horizontal velocity. So the horizontal velocity is going to stay 5 meters per second. However, the vertical velocity is going to start to develop. It's going to get a little bit stronger over here, and then as it falls, it's going to get a little bit stronger over here also. However, keep in mind the horizontal velocity stays the same. That's why we can call it an average velocity. But the vertical velocity will get a little bit stronger. Sorry about my handwriting here. The vertical velocity, let's tidy that up a little. The vertical velocity is going to get a little bit stronger. And then finally, the vertical velocity is going to be the greatest at this point. The horizontal velocity will stay the same. So you should draw the horizontal arrows the same as you did from the beginning. Horizontal velocity will stay 5 meters per second. The vertical velocity will be the largest right here. Now you can draw the vertical velocity right here, or you can do it the way we taught you how to do vector addition and draw them head to tail. So the vertical vector can be drawn right here. If you want to, you can draw it just right here. Just like over here, you can draw the vertical velocity over here, or you can draw it at this point. You can simply say, I'm going to draw it this way, head to tail. Your lines hopefully are going to be straighter than mine. Mine are a little bit messy. But anyways, the important thing to discuss is if somebody asks you how far does a ball land from the edge of the cliff. So they're asking you about the range. They're saying how far. They'll call it the R for range, or they'll call it X, or they can even call it D, whatever you want to call it, DX. Basically, they're asking you how far does the ball land from the edge of the cliff. Well, to figure this out, you need to know how much time the ball spends in the air. Well, what's the simplest way to find the time the ball spends in the air? Yeah, the simplest way is to analyze the ball's vertical motion. Well, what do you know about the ball's vertical motion? Well, you know a couple of things. You know that the ball's vertical motion started off with an initial vertical velocity of 0. You know that it's accelerating at negative 10 meters per second squared. And of course, you would have to know how high your cliff is. You'd have to know the displacement on the y-axis, how high your cliff is, your dy. So let's come up with a number and say the displacement of the y-axis is 20 meters. So if you know the initial velocity, the acceleration, and the displacement, you can figure out the time it takes for the ball to fall to the ground as it travels vertically. You're going to use your displacement equation. You're going to say final displacement is equals to initial displacement plus initial velocity times time plus 1/2 at squared. And you're going to notice a lot of things are going to drop out of this equation. If your final displacement, let's give it a number of 20 meters as we have, then your initial displacement, this you can call this your initial starting point. So this can be 0, and this is downwards negative 20 meters. So we want to make sure it's a negative because it's falling downwards. So this says equals negative 20 meters. As the ball falls, you can say that the initial displacement is 0, so this drops out of the equation. you know that the initial vertical velocity is 0, so initial vertical velocity 0 times t is 0, so this drops out of the equation. So simply you're left with dy is equals to 1 half at squared. Dy equals 1 half at squared. Your dy is negative 20, that's your displacement. Your a is negative 10, and you can solve for your t. Once you know your t, you can solve for your displacement, because if the ball has spent 1 second in the air, it's gone 5 meters to the right, because it's traveling 5 meters per second to the right. If it spends 2 seconds in the air, the time comes out to be 2 seconds, and the ball has gone 10 meters to the right. If the time comes out to be 3 seconds, and the ball has gone 15 meters to the right. So basically, what I'm saying is if you need to find the range, you simply go back to your kinematics equations. Average velocity is displacement over time. Now the displacement is the x displacement. So you can write the dx, or you can write it as x, or you can write it as r. But basically, you know this value, the horizontal velocity is 5 meters per second. That's governing how the ball is traveling to the right. And the time is something that you've calculated right up here, because you knew the a, you know the dy. The dy is negative 20, the a is negative 10. So plug in negative 10 for a, plug in negative 20 for your dy, solve for your time. And then your time can be substituted directly in here. Your time times the horizontal velocity will tell you the horizontal displacement, which is called the range. So that's how you can find the displacement. I've left this in variable form because you should know what the equations look like, and you should know that you can interchange them all the time. So these are your two important equations whenever you're talking about a ball or a projectile being launched horizontally. So it's being launched off of a cliff. Any object being launched horizontally is similar to this cliff problem. This is your horizontal analysis equation, and this is your vertical analysis equation. You can use these anytime. And in this case, I gave you the displacement dy, I gave you the vx, and I asked you to find the range. In other times, I'll give you the range, I'll give you the dx, and I'll give you the horizontal velocity. So you're going to know this, you're going to know this, and you're going to have to solve for t. And once you know the t, you plug in your t in here, and you multiply it with your acceleration of gravity, negative 10, and you'll solve for dy, and you'll solve for this number. In this case, it was given to you. So in other cases, it may not be given to you. So hopefully this horizontal motion practice problem was helpful.